Hello and welcome to the 5-1 Notes. This is a section over bisectors of triangles. And the first thing I want to do is talk about what a bisector is. A bisector cuts or divides a segment or angle in half, okay? Or we get two congruent parts. Okay, so however you think about it, a bisector cuts something in half for two congruent parts. And the first thing I want to talk about right now is what we call a perpendicular bisector. Okay, a perpendicular bisector. Okay, and so a perpendicular bisector is kind of just what it means. All right, we have a segment here, CD, is a perpendicular bisector. Okay, so it bisects segment AB, so we get two congruent parts and we form a right angle, okay? And so, let's go ahead and write this, that if CD is a perpendicular bisector, okay, of AB, okay, then we have two conclusions that we can draw. We know that AD is going to be congruent to DB, okay, and we know that AC is now going to be congruent to CB. Okay, so if you have a triangle here, and you know that your perpendicular bisector is right here. Let's say you know you have a perpendicular bisector. Then I know that any point along this perpendicular bisector will be equidistant to the endpoints of the segment that you bisected. Okay, so the conclusion that we can draw here is that AC is congruent to CB. Okay, now there's also a converse to this. There's also another way to think about it, and that's if you know that you have these two segments are congruent in a triangle and that these two segments are congruent, then you know that CD is a perpendicular bisector. Okay, so that's one thing that we know, and we've got a few other figures to talk about, so let's go ahead and take a look at those. Okay, so in this figure, we're going to call this the angle bisector. So angle bisector. Okay, and we've kind of talked about what an angle bisector is. So what I know is that if BF, okay, so if BF bisects angle DBE, okay, and FD is perpendicular to DB, and FE is perpendicular to BE, okay, then I can conclude that FD must be congruent to FE. Okay, so if I know that BF is an angle bisector, okay, it bisects this angle here, and if I form right angles here, then I automatically know that FD is congruent to FE. Okay, and similarly, if I know that I have these two, if I have this kind of picture here, and I know that these two lengths are congruent and 90 degrees, then I know that this bisects this angle right here. So we have to be able to go frontwards and backwards with this. And so let's go ahead and take a look at the next one. Okay. This next picture deals with what's called a circumcenter. So circumcenter. Okay. And this right here, that value here is the circumcenter. Okay, and what I want you guys to notice here is that what I've done with this triangle is I've found all the perpendicular bisectors of each of these sides of these triangles, okay? And what happens here is we end up getting that these values connect at the circumcenter, okay? And so what we know is that if I have a circumcenter, so if P is a circumcenter, then I know that the circumcenter is equidistant to all four corners of my, or all three corners of my triangle. So I know that the length of PB, okay, is congruent to the length of PA, okay, which is congruent to the length of PC, okay? And so this is true if I have perpendicular bisectors for all the sides of my triangles. And this will work in any triangle, okay? You may not get, depending on the triangle, it may not always be in the center. Sometimes it's outside, or sometimes it's actually on the side of the triangle. So we got to look for that. Okay, so let's take a look at the last one. Okay. And this is something that we call the incenter. Okay, and this is the value right here that is my incenter, okay, at that point. And so what we've done is we say that all of these lines coming out of this triangle, and it looks pretty similar to the last one, but all of these lines coming on this triangle have created angle bisectors, okay? So if we have an incenter that's created by the intersection of angle bisectors, then, so if point P is an incenter, okay, then I know that the perpendicular line coming from P to all of the sides of my triangle, okay, then I know that all those perpendicular lines are going to be congruent. Then I know that PD is going to be congruent to, say, PE, okay, which is going to be congruent with PF, okay? And so what I can do here is I can come in here and I can draw in congruent symbols right here and right here. Okay, let's go ahead and go back to this one. I forgot to do that. We know that PB, PA, and PC are all congruent, so let's go in here and let's draw that in, and let's draw that in with 4. Whoops. Okay, so that's going to be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So the way to recognize that the difference between a circumcenter and an incenter is that a circumcenter deals with what are they called? Perpendicular bisectors, okay, and the incenter is dealt with angle bisectors, okay, so you got to look out for that. So let's go ahead and take a look at some of the practice problems. Let's take a look at number 1, and it's asking us to find the measure of FG. Okay, it wants us to find this measure right here. In order for me to find that measure, I have to figure out what x is, okay? Now, the one thing that I know, okay, just by looking at this picture, is that EF is congruent to ED, okay? They're both 13. So I'm going to come in here and I'm going to draw in a congruent symbol, okay? And then I know that I have this line, EG, okay, and so EG, if these two segments are congruent and we form a 90-degree angle, then FG is going to be congruent to GD, okay? So let's say that. Let's say that EG, okay, we know that EG is a perpendicular bisector of FD, okay? And so that's what I know. Okay, so if I know that those are perpendicular bisector, then I know that FG is congruent to GD. So let's go ahead and set up an equation and solve that. So let's set up 5x minus 17 is equal to 3x plus 1. Okay, and if we solve for x, I'm going to subtract 3x from both sides, and we're going to get 2x minus 17 is equal to positive 1. Okay, let me write that over here. 2x minus 17 is equal to positive 1. Let me add 17 to both sides. Okay, so I get 2x is equal to 18. Divide by 2, divide by 2. I end up getting that x is equal to 9. Okay, So if x is equal to 9, then I can find the measure of FG. And so FG is equal to 5 times 9, okay, minus 17. Okay, and you can plug it into either FG or GD because they're congruent. But we'll just go ahead and keep it like we've got. So I'm going to do 45 minus 17. So we end up getting that FG is a value of 28. Okay, so I'm going to write that up here. FG is equal to 28 units. Okay, so that's my answer. Okay, let's go ahead and take a look at number 2. Okay, and so, the thing that I know here, it wants us to find the measure of angle LYF. So the whole measure, angle LYF. Okay, so here's what I've got to do. I know that JL is congruent to LF. So if those two values are congruent, okay, then I know that we make a perpendicular line right here, and perpendicular angle right there. Okay, then I know that LY, so I'm going to write this, LY is an angle bisector of angle JYF. Okay, and so since that's the case, then I know that these two angles are congruent. Okay, so if it wants me to find angle LYF, I know this is 58 degrees. I can then conclude that angle LYF is also equal to 58 degrees because they are congruent. Okay, so let's go ahead and take a look at the next one. This is dealing with a circumcenter. Now let's just recap because I always kind of forget what a circumcenter does. Okay, a circumcenter means that if P is a circumcenter, then the point from P to all the corners of the triangle are congruent. So let's go ahead and come in here. And it says that point P is the circumcenter of triangle ABC. So let's come in here and let's figure out, okay, what we know. Okay, I know that PB then is going to be congruent to PA and PC. Okay, all of those are congruent. Okay, and I also know that these two segments are congruent. Okay, I know that these two segments are congruent. And these two segments are congruent. Okay, so we got to be able to label our triangle. Okay, so now let's go ahead and take a look and see what they're asking. Okay, so it says list any segments congruent to each of these segments. So which segment is congruent to BR? Okay, and that would be RA. Okay, so this is going to be RA. Okay, I'm going to put a little congruent symbol there. And then number 8 is asking what is congruent to CS. Okay, and so here's CS. I know that AS is congruent to CS. So I'm going to come over here and write that this is congruent to, what was it, CA? No, AS, sorry. AS, okay, is congruent to CS. All right, then segment BP, okay, BP has a couple other congruents. So here's BP that's congruent to AP and to CP. All right, so I'm going to put both. Okay, we are congruent to AP and PC, CP, whichever. Okay. All right, now let's take a look at 10, 11, and 12. Now what I know is that A is the incenter. Okay, and an incenter, all right, creates perpendicular angles here, here, and here. Okay, but it also bisects all of these angles. Okay, so I'm going to do this. I'm going to go ahead and call that these two angles are congruent. I'm going to call these two angles are congruent. And I'm going to call these two angles congruent. Okay, so that's what we need to, the conclusion we need to draw here. Okay, so then it wants us to find the measure of angle ARU. Okay, and what is that? ARU is right here. Okay, so here's what I know. I know that ARK is 40 and that's congruent to ARU. So I'm going to come in here and write that angle ARU is equal to 40 degrees, okay? And then it wants me to find segment AU, find the length of segment AU. Okay, and the one thing I forgot to do was to mention here that if I have an incenter, then I know it's congruent to all of these sides. Okay, so if AT, okay, is 20 units, then I know that AU is also going to be 20 units. Okay, 20 units. Okay, the last one on number 12 wants us to find the measure of angle QPK. So it wants us to find this angle measure here. Now, it's given me an algebraic expression for here and here, and I know that these two angles are congruent, okay, because this is an incenter, and an incenter bisects this angle. So I'm going to go ahead and set up an equation, and I'm going to set up 3x plus 2 is equal to 4x minus 9. All right, I'm going to go ahead and subtract 3x from both sides, and so I get 2 is equal to x minus 9. And if I add 9 to both sides, okay, then I end up getting that x is equal to 11. Okay, did I do that right? Yeah, okay. So we're good on that front. Okay, so now we want to find angle QPK, okay? And I know that that angle measure is 3x plus 2. All right, so I'm going to substitute 11 in for x, so I get 3 times 11 plus 2, and so I end up getting 33 plus 2, which ends up giving us that this is 35 degrees, okay? And that's the answer that I'm looking for. Okay, so I hope you enjoyed this video. I know it's a lot of information to take in, but if, remember guys, if you just have these 4 things written down, okay, and it tells you either by the picture or by what it's saying, okay, we need to be able to draw all these conclusions, okay? So try and use these ideas to help, and we will see you soon. Thank you. Bye.